हेलो माय डियर मैकेनिकल चैंपियंस, कैसे हैं सब लोग? व्हाट्सअप, प्लीज डू ज्वाइन मी फास्ट so that we can start this wonderful session on time. So I welcome you all to this ISRO 2023 practice course. Here we are discussing the most important, most expected type of question for ISRO exam. I hope your preparation is going well for ISRO 2023. So today I will be going to discuss 25 questions, few questions from the fluid mechanics and some questions from the heat transfer. All right. So please first do let me know if my audio and visual quality are fine so that we can start this session. So before I start my session, let me quickly introduce myself for those who are attending this session for the very first time. My name is Chandrasekhar. I am having more than 10 years of teaching experience in the field of GATE, IES and PSUs. Just hold on. Give me a moment. And please do let me know. Please mark your presence by writing in the comment section. Is my audio and visual quality are fine? And keep your pen, notebook along with you so that you can solve the questions, and do let me know your answer through the comment section. All right. So let us start without any delay. Yes, can you see my screen now? So I was talking about my introduction. I am having more than 10 years of teaching experience in the field of GATE, IES and PSUs. I am mechanical engineering graduate from IIT Delhi. I have also cleared engineering services examination conducted by UPSC, worked in Steel Authority of India Limited for a couple of years, and I am quite comfortable in the mentioned subjects for mechanical engineering: fluid mechanics, heat transfer, thermal and industrial. If you have any doubt, anything to ask, can you just write something in the comment section, those who are watching me live, so that I will come to know whether I am able to see your comments or not. This is my mail ID. For those who want to have any type of discussion, you can always connect with me. And it will always be beneficial for you if you join me on the Telegram. My Telegram channel is Mechanical by Chandrasekhar, and the link is also mentioned at the bottom of this screen. All right. So a couple of information and then we will proceed for the question. There are 25 questions in total, and we will try to solve those 25 questions within 45 minutes of time span. Hi Vinay, welcome, good morning, welcome, how are you? So there is an important series we are going to start from 3rd of July for GATE 2024 aspirants. 50 mark series. In 40 days we will make you get 50 marks in your GATE 2024 examination. So do subscribe our BYJU'S YouTube channel if you have not subscribed it yet. And there is a beautiful important workshop going to be conducted on 2nd of July at 12. The session will be taken by Dheeraj sir and Abhinav Negi sir, who are having more than 10 plus years of teaching experience. They will guide you to secure all India rank under 100 in just 7 months of your preparation. So the workshop is completely free for all the students. You just have to register yourself, and the link is already mentioned in the description box of this session. So please do like this session, guys, so that it reaches to all your friends and colleagues who are preparing or who are aspiring to be part of ISRO. All right. So please keep your pen and notebook. Shall we start? There is the first question on the screen. Let me know your answer for the question number 1. Every one of you, quickly, which property of mercury is the main reason for its use in barometer? You should understand that mercury is the suitable barometric fluid. What is barometer? It measures the atmospheric pressure. The instrument used to measure the atmospheric pressure is called as barometer, and the atmospheric pressure is also called as barometric pressure. And the barometer are also used for the weather forecasting. What is the correct answer? Actually, there are two reasons. One is because of high density of mercury. Density of mercury is high. That is one of the reason. And the vapor pressure of mercury is very low. That is another reason. So there are two correct reasons of selecting the mercury as the barometric fluid, but the more appropriate, if the question is MCQ, then you are supposed to select the most appropriate answer. The most appropriate answer is very low vapor pressure, so that the reading of the barometer accurately measures the local atmospheric pressure. The high density is also another reason, but that is the secondary reason. So whenever it is MCQ, then you are supposed to select only one answer, one option. And if it is MSQ type of question, then both A and C will be correct. Do you agree? Do you understand it? Yes, Kiran, well done. Vinay, good, 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 good. I want every one of you, it is my humble request, the more you share your knowledge, the more you take part in the discussion, the more improvement you will develop in your understanding of the concepts, right? So whether your answer is correct or incorrect, it does not matter at all. But your participation is highly important to start applying, to get the application of the concept in the questions. All right. So the question number 2 is on your screen. What is the pressure inside a soap bubble over the atmospheric pressure if the diameter of the soap bubble is 2 centimeter and the surface tension is 0.1 Newton per meter? This is the unit of surface tension, Newton per meter, or we can also call it as Joule per meter square. Do you know that surface tension can also be defined as the surface energy per unit surface area of the liquid? Yes, because it is a soap bubble. So delta P for a soap bubble is having two interfaces. So 8 sigma by D will be the expression. If it would have been an air bubble, do not get yourself confused. Air bubble or liquid drop are having only single interface. Air bubble or liquid interface, delta P will be given by 4 sigma by diameter. So delta P is the pressure difference. If you put the values 8 into 0.1 upon diameter, that is 2 into 10 to the power minus 2. If the answer is in Pascal, then the correct answer will be, what is the answer? Every one of you. Yes, Kiran, Naruto, well done. What about others? Vinay, good, good. 40 Newton per meter square will be the correct answer for this one. Question number 3 on your screen. Question number 3, quickly get me the answer for question number 3. Pressure reaches a value of absolute 0. It means absolute pressure becomes 0 Pascal. When does this happen? When does this happen? At a temperature of minus 23 Kelvin, minus 23 Kelvin never exists. At an absolute 0, the temperature absolute is equal to 0 Kelvin. At the absolute 0, the pressure will be 0 Pascal and the temperature, absolute temperature will be 0 Kelvin. Under vacuum condition, what is vacuum condition? Vacuum condition is when the pressure becomes less than PATM. When the pressure, absolute pressure is less than atmospheric pressure, then it is called as vacuum condition. At the earth center, that is not correct. At absolute 0, molecular activities stops. At absolute 0, molecular activities stop. So that is why the answer to this question is option D. When molecular momentum of the system becomes 0 or the molecular velocity becomes 0, then only the pressure will be absolute 0. Because the pressure is the pressure exerted by the molecules. When the molecular momentum is 0, the pressure will not be, pressure exerted will be 0. Question number 4 on your screen. How is the metacentric height gm expressed in case of a floating body? Metacentric height is the parameter defined in case of a floating body or a partially submerged body. It is memory based question, formula based question. What is the answer? Yes. Well done. So for stable equilibrium, center of buoyancy is lying below then center of gravity and the metacenter. So metacentric height is gm. This is called as metacentric height. Gm is equal to bm minus bg, isn't it? And what is bm? Bm can be calculated by I minimum moment of inertia upon volume of the displaced fluid minus bg. That is the expression for metacentric height. I is the minimum moment of inertia. It is the minimum moment of inertia of the plane of the floating body, and v is the volume of body submerged in water or volume of the fluid displaced. Bg is the distance between the center of gravity and the center of buoyancy. What is the correct answer? The correct answer for this question will be option C. Question number 5th on your screen. Question number 5th, try to solve question number 5th. It is numerical, simple numerical. Without using the calculator, you are supposed to get me the answer to this one. Can you do that? Yes, every one of you. Naruto. This Telugu, I do not understand your name. What is your name? Kiran is saying B. The pressure in Pascal corresponding to 3 centimeter column of mercury. The pressure can be written. Santhia. Okay, Santhia. Please check your calculation once again. Is it A or B? The pressure in Pascal corresponding to 3 centimeter column of mercury. The pressure can be written in terms of pressure head of a liquid column. So if we want to convert it into Pascal, then rho of the mercury, rho of the liquid column into G into H, the height of the column. If you put all the parameter in their SI unit 13,600 into, let me take GS 10 to get the answer nearest to the correct option. And 3 centimeter is equal to 3 into 10 to the power minus 2 meter. That will give you the Pascal. So if you simplify this, then you will get it as 136. These two will get cancelled out. 0 into 3. It is 1360 into 3 Pascal. So it is close to 3900 something, isn't it? B is the correct answer. Option B. Yes, it is close to 3900. B will be the answer. Good, good, good. Let us move to the next one. So those who have joined me recently, there are important links in the description box. Do go through the description box once the class gets over, and do not forget to like and share this session so that more and more students can join us and get benefited. Next question on your screen. There is a centrifugal pump delivers a manometric head of 12 meter when pumping a liquid of relative density 0.8 meter. If all the other factors remains the same, but the liquid is now having a relative density of 1.2, what will be the new manometric head? Can you find out? So all the other factors remain same. What does that mean? Power and discharge remains constant. They remain same. All the other parameters remain same, power and discharge. We need to find out the manometric head as a function of density or specific gravity. The manometric head and specific gravity are interrelated, right? So can we say the power supplied by the pump is equal to m dot into G into HM, or the head raised by the pump? Manometric head, this is the manometric or power raised by the pump. M dot GHM. M dot can be written as rho into Q into G into HM. That will be the expression of power. So because discharge is constant, power is constant, can we say HM is inversely proportional to density? Can we write HM is inversely proportional to density, isn't it? So we can say HM2 by HM1 is equal to rho 2 by rho 1 or rho 1 by rho 2. It will be rho 1 by rho 2. What is rho 1? If we write in, we can write in terms of specific gravity also. So S1 is 0.8, S2 is 1.2 and HF1 is 12 meter. So 12 into 8 by 12. So 12 into 2 by 3, isn't it? What is the answer? 24 by 3. A will be the correct answer, 8 meter. Yes, Kiran, Vinay, Naruto, well done. Correct answer is option A. The next question on your screen. Try to solve the next one. There is an isosceles triangular plate. What is the meaning of isosceles triangle? Two sides are equal, of base 3 meter and altitude 3 meter. The base and height are 3 meter, is immersed vertically in an oil of specific gravity of 0.8. The base of the plate coincides with the free surface of oil. We need to find out the depth of center of pressure. The depth of center of pressure from the free surface of the liquid. There are two different parameters. One is the depth of centroid of the surface. Another is the depth of center of pressure. What is the depth of center of pressure? The depth of center of pressure is the point. The center of pressure is the point at which the pressure force or the hydrostatic force is supposed to be acting on the surface. What is the centroid? Centroid is the point, the point where the gravity force is supposed to act. That is called as centroid of the plane surface. So can you do the calculation? The base of the plate coincides with the free surface. So the diagram will be something like this. If you know the shortcut, so if we want to find out the depth of centroid from the free surface, that we call it as x bar. So if the question would have been about x bar, your answer would have been 1 by 3 into h into 3. Whether it is isosceles or not, it does not matter. Whether it is isosceles or not, it never matters. So 1 by 3 into 3, 1 meter is the depth of this. Now, if we want to find out HCP, then we can say x bar is 1 by 3 into x bar. Then we can add 1 in the numerator and 1 in the denominator. That is the short trick to memorize it. So 2x bar by 4. So x bar by 2. What happened? One by 3, sorry. X bar by 2. What is the answer? How it is happening? What happened? X bar is equal to, what is the depth of CP? X bar is 1/3 of h, sorry. So it is HCP will be equal to 1/3 of h. Put 1 and 1 in the numerator and denominator. So it is 2 by 3 h. Sorry, my mistake. This is the trick. Sorry, 2h by 4. This is the trick to memorize it. 2h by 4. Add 1 in the numerator and add 1 in the denominator. X bar is equal to h by 3 or 1 by 3 h. X bar is given as, this is the trick to memorize. Those who have attended my theoretical session, they must know. So x bar is equal to 1 by 3 into h. If we want to find out the depth of CP, then 1 by 3 h add 1 in the numerator and add 1 in the denominator to get the answer. So it is 2h by 4. So h by 2. So it will be 1.5 meter. C is the answer. The answer will be C. Or you could have done the calculation. What is the formula for HCP? That is x bar plus Ig by Ax bar. That is the formula. What is x bar? X bar is equal to 1 plus Ig will be equal to BH cube by 36. 3 into 3 cube by 36 into half into B into H into x bar. If you do the calculation, you will get it 1.5 meter. 3 getting cancelled out with this 3. So 1 plus 9 by 18. So that is 1 plus 1 by 2. 3 by 2. That is 1.5 meter. That is another way of getting the answer. The next question on your screen. The next one. In a 1 in 50 model of a spillway, 1 in 50, it means that is the geometrical scale ratio. That is the geometrical scale ratio of a spillway. Discharge is 3 meter cube per second. Find the corresponding discharge in the prototype. QM is given. We need to find out QP. What is the discharge in the prototype? Can you solve it? Can you get me the answer? If it is a spillway, in case of a spillway, do you know what is a spillway? The gravity becomes important. In case of a spillway, gravity will be important. So if the gravity is important, then the Froude model law will be applied. Froude number will be constant, that is equal to V upon under root of L into G. So from here we can say V is directly proportional to root L and Q is proportional to D square into V. So Q is proportional to L square into root L. Q is proportional to L to the power 2 plus 1 by 2, 5 by 2. So QP by QM is equal to LP by LM. So we can say QP by QM is equal to LP by LM to the power 5 by 2. So QP, do not use the calculator. Who is using the calculator? Anyone using the calculator? Prototype, the dimension of the prototype will be 50 unit and the dimension of the model will be 1 unit. So it will be 3 into 50 by 1 to the power 5 by 2. Right? So it can we write it as 3 into what is root of 50? Can you find out the value of root of 50? That is close to 7. 7 7s are 49. So it is close to 3 into 7 to the power 5. If you will do the calculation, your answer will be nearest to the option C. Your answer will be nearest to the option C, isn't it? That is how you can do the calculation without using the calculator. It is close to 7 to the power 5 multiplied by 3. And 7 to the power 5 you can easily solve without using the calculator. The next one. Which one of the following statements is correct? Dynamic viscosity is the property of the fluid which is not in motion. Is the statement correct or not? Dynamic viscosity. Why do we call it as dynamic viscosity? Because it gives us the information about the dynamic parameter, which is shear stress or shear force required to make the fluid flow. That is defined as the dynamic viscosity. We also call it as absolute viscosity because mu is not a function of density. It is also called as absolute viscosity. What is the correct answer for this one? Cavitation results from the action of very high pressure. Cavitation results from the action of very low pressure. When the pressure becomes, so C is incorrect. When the pressure of the liquid becomes less than the vapor pressure, then cavitation bubbles form. So C is not correct. Real fluids have lower viscosity than ideal fluids. Ideal fluids have zero viscosity. Real fluids are having non-zero viscosity. So ideal fluids are having low viscosity than the real fluids. So D is also incorrect. What about A and B? Dynamic viscosity is the property of the fluid which is not in motion. That is incorrect because dynamic viscosity is the property of the fluid whether it is in motion or not. It does not matter whether the fluid is in motion or not in motion. Surface energy is the fluid property. Surface energy is nothing but the surface tension. It is surface tension. Surface energy is the property of the fluid giving rise to the phenomena of capillarity in water. Yes, the capillarity is because of surface tension. So B is the more appropriate answer. Right? The next one. Let C1 be the velocity of pressure wave traveling along rigid pipe containing water with its bulk modulus this much. Let C2 be the velocity traveling along a rigid pipe carrying oil of relative density 0.6. The previous pipe is carrying water. Now this pipe is carrying oil of relative density 0.6 with its bulk modulus this. Through a similar pipe, what will be the ratio of C1 by C2? What will be the ratio of C? C is the velocity of the pressure wave or velocity of speed, velocity of sound in fluid. What is C? What is the formula for C? C is calculated by under root of K by rho. C is equal to under root of K by rho. So C1 by C2 is equal to under root of K1 by K2 into rho 2 by rho 1. Put the value, you will get the answer. What is K1 by K2? K1 is 2.16 into 10 to the power 9 and K2 1.296 into 10 to the power 9 into rho 2, that is 0.6 upon 1. Right? So if you simplify this, 2.16 or we can say under root of 2.16 into 6 upon 12.96. So 2.16 into 6 is nothing but 12.96. So that will be root of 1. That will be root of 1. So root of 1 is 1. Option C will be the correct answer. Option C. The next question on your screen. Regarding the viscosity. As the temperature increases, viscosity of air decreases. Is the statement 1 correct or incorrect? Statement 2 says as the temperature increases, activity of air molecules increases. So if the temperature increases, viscosity of the liquid decreases and viscosity of the gas increases. So viscosity of the gas will not decrease. So this statement 1 is incorrect. Statement 1 itself is incorrect. And as the temperature of air increases, activity of the air molecules increases. Yes, increase in molecular collision. Molecular collision increases or molecular momentum transfer increases. That will increase the viscosity of the gas at higher temperature. So 2 is correct. Statement 2 is correct, but the statement 1 is incorrect. So option D will be the correct answer. Yes, aspirant. Welcome. When did you join? Good. D will be the correct answer to this one. The next question. Solve the next one. Find the answer to the next one. A pressure gauge reads 57.4 kilopascal and 80 kilopascal respectively at a height of 5 meter and 3 meter fitted on the side of a tank filled with a liquid. We need to find out the density of the liquid. So the pressure here is 80 kilo, pressure is less at the top, pressure is more at the bottom. This is 57.4, this is 80, and the distance will be equal to, this is 5 meter, this is 3 meter, 8 meter and 3 meter. So the distance will be equal to, this is h. So can we write rho of the fluid into G into h is equal to 80 minus 57.4 kilopascal. We can write the pressure equation. Let me call it as A, let me call it as B. If we write the pressure equation, then we will say pressure at A plus rho fluid into G into H is equal to pressure at B. And pressure at B is 80 kilopascal. Pressure at A is 57.4 kilopascal. So we can find out the density of the fluid is equal to 80 minus 57.4, 22.6 into 10 to the power 3 upon 9.81 into H3. 9.81 is almost 10. Let us write it as 10 only. So what will be the answer? So it will be 2260 by 3. That will be the density. So 1120. It is close to 1120. Sorry. 768. Yes. 2260 by 3. It is close to 768. Acha. Good, good, good. B is the answer. The next one. Find the answer to the next question. Question number 13. There are 25 questions in total. We are halfway. A mercury water manometer has a gauge difference of 0.8 meter. This is mercury and there is a water flowing. There is a water. And the manometric fluid deflection is X. So we need to find out the pressure difference in meter of water. In meter of water. If we want to find out the pressure difference in meter of water, so delta P by rho G is equal to manometric fluid deflection SM by SF minus 1. So it will be 0.8 meter is the difference, 13.6 by 1 minus 1. So 12.6 into 8 meter of water will be the answer. 12.6 into 8.8. So it will almost be 10.05. C will be the answer. Yes. Yes, Kiran, Naruto. Well done. 10.05 will be the correct answer. The next one. Can you see the figure? Are you able to see the figure? Consider the figure below relating to the buoyancy in water. There is a body completely submerged. What will be the downward force upon the top of the body? A, B, C, D, E, F. Yes. What should be the answer? The body is A, B, C, D, E, F. What will be the, how to calculate the downward force acting on the body? Yes. Your turn. Let me know the answer. The downward force exerted, on the body is equal to weight of the fluid which can be contained by the vertical hydrostatic force is the weight of the fluid which can be contained by the curve up to free surface. Extend A and B up to free surface. This volume, this volume will decide the downward force, FV1. and upward force will be decided by this volume. Upward force will be calculated by this volume, and net upward force will be the subtraction. So downward force will be equal to weight of A, B, C, G, H or HG. A, B, C, HG. And FE2, if we find out FE2, then it will be A, F, E, D, C, G, H. That is FE2. And the difference of these two will be the buoyant force. The difference of these two will be the buoyant force. So what will be the downward force upon the body? So option A will be the right answer. It will be option A. Question is to find out the downward force. If we want to find out the downward force on a surface, this is the surface. If we want to find out the downward force on the surface, extend the edges normally up to free surface. So weight of the fluid which can be contained by the curve up to free surface. So Fe1 will be the weight of ABCHG, and Fe2 will be the weight of AFEDCGH, and the difference of these two will be the buoyant force. Isn't it? Are you getting it? So option A. It is not the net force. Net force will act in upward direction. Aspirant, net will not act in downward direction. Net will be Fe2 will be greater than Fe1. So buoyant force will be equal to Fe2 minus Fe1. That is the buoyant force, which is upward. Net upward force will be acting in vertical force will be acting in upward direction. The next question on your screen. The next one. A ship has a metacentric height of 0.9 meter. What is the metacentric height? That is GM. And its period of rolling is 20 seconds. That is the time period of oscillation. The relevant radius of gyration will nearly be. So time period of oscillation is given by 2 pi under root of Rg square upon G into Gm. Rg is called as radius of gyration. Rg will be the radius of gyration. So can we say from here time period is 20 seconds, 2 pi into under root of Rg will be Rg only upon under root of G, let me call it as 10 into Gm, that is 0.9. So your answer for Rg will almost be equal to, what is 10 into 0.9 under root? That is 9 under root of 5. So 20 into 3 upon 2 into 3.14. So it is around 30 upon 3.14. Isn't it? So it is close to 10. It is slightly less than 10. Option C. It is slightly less than 10. Kiran, are you using the calculator? How you are getting so accurate value? Do not use the calculator. ISRO will not allow you to use the calculator. So try to do the calculation correct without using the calculator. The next question, there is a two-dimensional water jet which strikes a fixed two-dimensional plate at 30 degree to the normal to the plate. A two-dimensional, this is beautiful question. What is the answer to this one? A two-dimensional water jet strikes a fixed two-dimensional plate at 30 degree to the normal to the plate. This is normal to the plate. and this is how the water is striking, isn't it? This is 30 degree. Some fluid will be going like this, some fluid will be going like this. This is the tangential direction. Isn't it? So if we write the momentum equation in tangential direction, if we write the momentum equation in tangential direction, Ft will be equal to 0. Ft will be equal to 0. That is equal to, this is Q, this is Q1, this is, let us say, Q2. So that is equal to rho QV sin 30. That is the initial momentum minus rho Q1 minus Q2 into V. Isn't it? So from here we can say Q is equal to, or Q1 minus Q2 is equal to Q sin theta. Are you able to understand it or not? Do you guys understand it? Whenever we are supposed to develop the relation between Q1 and Q2, the question is to find out Q1 by Q2 will be how much. So can we say Q1 minus Q2 is equal to Q sin theta, and Q1 plus Q2 is equal to Q? That we all know. This is 1, this is 2. So if we add these together, then what will be Q1? So 2Q1 is equal to Q1 plus sin theta, isn't it? So Q1 is equal to Q by 2, 1 plus sin theta. And what about Q2? Q2 is equal to Q minus Q1, that is equal to Q minus Q by 2 Q minus Q by 2, 1 plus sin theta. So it will become Q minus Q by 2, that is Q by 2 minus sin theta, that will be 1 minus sin theta. So Q1 by Q2 is equal to 1 plus sin theta upon 1 minus sin theta, isn't it? So Q1 by Q2, 1 plus sin theta, theta is 30 degree, this is theta, sin 30 upon 1 minus sin 30. That will be the answer. 1 plus sin 30 upon 1 minus sin 30. Sin 30 is 1 by 2. So 1 plus 1 by 2 upon 1 minus 1 by 2. 3 by 2 upon 1 by 2. So the answer will be B. B will be the answer. B will be the correct answer for this one. It will not be A. Do not memorize the formula without knowing the concept. So that is the learning through this question. So let us move to the next ones. Then now there are some questions from the heat transfer. We have discussed around 16 questions from the fluid mechanics. The next question is from the heat transfer. A small sphere of outer area. There is a sphere, let me call it as 1. So A1 outer area 0.1 meters, 0.6 meters square is totally enclosed by a large cubical hall. This is surface 2. The shape factor of hall with respect to sphere is, so F2 to 1 is equal to 0.004. What is the measure of the internal side of the cubical hall? Let me call it as L. L is the side of the cubical hall. Then we can say F2 to 1 is A1 F1 to 2 upon A2 from the reciprocity theorem. What is the answer? Can you find out the answer to this one? And F1 to 1 is equal to 0 because it is a convex surface. For a convex surface, self shape factor is 0. So F1 to 2 is equal to 1 from the enclosure theorem. So 0.004 is equal to A1 by A2, and A1 is 0.6, A2 is 6L square. So we can easily find out the value of 0.6 by 6 is 1 by 10. So 10L square is equal to 0.004. Sorry, 10L square is equal to 1 upon 0.004. So L square is equal to 1 upon 0.04. And what is L? Can you find out the value of L? Under root of 1 upon 0.04. So 100 by 4, under root of 100 by 4, under root of 25. B will be the answer. 5 meter will be the correct answer for this one. The next question, memory based question. The formula. Which one of the following expresses the thermal diffusivity of the substance in terms of thermal conductivity, mass density and specific heat? What is the answer? What is thermal diffusivity? Heat transferability. And the unit is meter square per second. Sorry, yes, the unit is meter square per second. It is similar to similar to Prandtl number. Sorry, is the unit of thermal diffusivity? It is similar to kinematic viscosity, momentum diffusivity. So K by rho C will be the unit. What is the answer? K by rho C. The ratio of thermal conductivity to the heat storage ability, that is called as thermal diffusivity, K by rho C. The next one, from the conduction. Next is the question from the conduction. There is a furnace made of red brick wall of thickness 0.5 meter and thermal conductivity 0.7 for the same heat loss and the same temperature drop. Q and delta T are same. This can be replaced by a layer of diatomite earth of conductivity K2 and the thickness L2 will be how much? Question is to find out L2. So from the conduction or Fourier law, Q is equal to Ka delta T by L. For a plane wall, the heat transfer rate is given by Ka delta T by L, which is constant. So here area will be same because it is not given. Delta T is constant given. So we can say K by L is constant. Or we can say L is directly proportional to K. So L2 by L1 is equal to K2 by K1. We need to find out L2. L1 is 0.5 into K2 by K1, 0.14 upon 0.7. Can you solve it? Point 0.5 by 0.5 into 0.2. That is 0.1. P is the answer. Yes, Naruto, Vinay, Kiran, well done. Good. The next one. From the critical thickness of insulation, there is an electrical cable. Cable means a cylinder of aluminium conductor. Thermal conductivity of aluminum is given by this, is to be insulated with the rubber. The cable is to be located in air. The critical radius of insulation will be. What will be the critical radius of insulation? Critical radius of insulation for a cylinder is the ratio of thermal conductivity of insulated material divided by the convective heat transfer coefficient of the medium in contact with the insulating material. So here this is not important. 240 watt per meter Kelvin is not important. The important parameter is 0.15 because insulating material is rubber. Divide by 6. Can you solve it? meter. If you want to convert it into millimeter, so 1000 by 400, 10 by 4. How much is the answer? Yes, 150 by 6. One by 40, na? 1 by 40. 1000 by 40. 100 by 4, 25 mm. A will be the answer. Yes, aspirant. 150 by 6 mm. Either you say 150 by 6 mm or 100 by 4 mm. The next one. At a given instant of time, temperature distribution with an infinite homogeneous body is given by this function. Determine the rate of change of temperature with respect to the time at the point this. Assume constant properties and no internal heat generation. So we will use the expression governing differential equation where the temperature is a function of x, y, z and t. So what we can say, because temperature is not a function of time, as the temperature is not a function of time, or let us write the governing differential equation, d square t by dx square plus d square t by dy square plus del square t by del z square plus q dot by k is equal to 1 upon alpha del t by del tau. We need to find out this. Q dot by k is 0. So that can be written as del by del x. The first term will be, so del t by del tau is equal to alpha, then del by del x, del t by del x plus del by del y, del t by del y plus del by del z and del t by del z. So alpha into what is del t by del x? Del t by del x will be equal to del by del x multiplied by 2x minus y plus del by del y. What is del t by del y? Minus 4y minus x plus 2z plus del by del z, then 2z plus 2y, then again differentiate. Del by del x, 2x is 2, then minus 4 plus 2. 0 will be the answer. 0 will be the answer. The answer will be 0. All right. The next one, the temperature curve. The temperature variation in a plane wall with uniform heat generation per unit volume is. So what is the correct answer? This is the temperature profile for a single wall. For a single wall with heat generation is equal to 0 and steady state. And this will be the curve for composite wall. This is not for the composite wall actually. So whenever there is a heat generation, then the temperature is a function of x square. That is parabola. That will be parabola. B is the answer. This will be when the thermal conductivity is variable 1 minus beta T. This will be the curve when the thermal conductivity is variable, right? The next question. The next one, fin effectiveness is enhanced by. What is fin effectiveness? That is Km by H, or we can write it as K by H. M is equal to M is fin coefficient under root of HP by Ka, or we can say fin effectiveness is given by under root of Kp upon HAC. So the choice of the material of higher thermal conductivity, yes, effectiveness of the fin is directly proportional to root K, that is correct. Effectiveness of the fin is proportional to under root of P by A, and effectiveness of the fin is inversely proportional to root H. These are the three relationships. So increasing the ratio of perimeter to the cross sectional area is also correct. So A and B both are correct. So the correct answer is option C. Yes, Sagar, we will plan. And the last question from my side. Match the column. Thermal time constant is from the question is from the unsteady state conduction. Thermal time constant, what it represents? Thermal time constant is representing the rate of response of the system to the change in environment temperature. Biot number is the ratio of internal conductive resistance to the surface resistance of the fluid, and the Fourier number, degree of penetration propagation of the heat wave across a given depth. Degree of penetration of heating or cooling effect throughout the solid. So 1 R 2 P 3 Q. P R P Q. R P Q. B is the answer, isn't it? B will be the correct answer, right? So that one more question, one last question for the session, the last question from my side, and then I will stop and we will meet again for the next session. Today at 5 p.m. there will be another session on YouTube for second law of thermodynamics. Do not forget to join me today at 5 p.m. for the second law. Important question I will discuss from the second law of thermodynamics. The question says air enters a counterflow heat exchanger at 70 degrees Celsius. If we draw the temperature curve, air enters at 70 and leaves at 40, water enters at 30 and leaves at 50. What is the LMTD? It is simple formula based question. So LMTD is equal to delta Ti 70 minus 50, that is 20, minus delta T naught 40 minus 30, that is 10, upon natural log of 20 by 10. So it is 10 upon ln of 2. What is natural log of 2? If you do not know the value, you will not be able to solve it. So 10 upon 0.693 will be the value of delta Tm. 10 divided by 0.693. Can you do the calculation? 10,000 divided by 693. We can call it a 693 is almost 700. So 10,000 upon 700. So we can say it is almost 100 by 7. 14.43 something. 14.43. 100 by 7 something. Yes, aspirant. Sagar. Well done. B is the right answer for this one. So that is all from my side, guys. Thank you very much for joining in. You can always connect with me through the mail ID, and I will share the PDF of this session to my Telegram group. That is Mechanical by Chandrasekhar. If you are not part of my Telegram channel yet, please do not forget to join me on the Telegram, and do not forget to attend the evening session at 5 p.m. on the same platform for the second law of thermodynamics. All right. So let me take your leave, guys. Thank you very much. Stay safe, stay motivated, and keep preparing it with your full dedication.